Okay, all right, let's get started for today. So Tiffany will be out today since she's feeling under the weather, so I will be teaching lecture today just by myself. Okay, so today is going to be our 8th lecture, and this will be actually the last lecture that we're going to be doing in UIKit. So everything that we've been doing so far has been in one development framework called UIKit, and in later lectures, actually on Wednesday, you'll see that we have a guest lecturer who's going to sort of teach you another development framework. But this last lecture sort of concludes everything you really need to know about UIKit iOS development. So without further ado, let's start at some announcements today. Okay, so if you guys check on EdStem, you guys have been all added to a hack challenge at EdStem, which is labeled as, I believe, CS/info 1998. And this is sort of where most of our communication is going to be done. So I'll also probably send on our current EdStem a link to that if you guys haven't been added already. But in terms of upcoming dates, there is going to be a hack challenge team mixer on Friday. So if you guys don't already have teams planned for the hack challenge, this is going to be a great opportunity to meet new members. We'll sort of mix and match you guys around. And I'm not sure, there may or may not be free food and beverage provided. I'm not sure on that, but yeah, you guys should, if you guys still are in need of a group, make sure you guys go there. And keep in mind that is April 19th, which is also the deadline to where the partner matching form is due. So keep in mind that's also sort of displayed on our EdStem here. So I can show you guys. So most of you guys have been added to this hack challenge EdStem here. I've already made a first announcement here with some important dates as well as some action items. But yeah, just to reiterate that. Okay. Also, keep in mind, A3 is also due tomorrow night, and keep in mind this is going to be the final submission, so you guys will actually be submitting something. So like A2, you guys will be submitting a text file with your GitHub link, NetID, as well as names. And also, like I mentioned before, so since this is going to be the last lecture on UIKit for iOS development, the next lecture on Wednesday and potentially on next Monday will be in SwiftUI, which is another development framework that you can do with iOS development. Okay, just a bit of a recap from last lecture. So last lecture, we went over a lot of part 2 of networking, which went into a lot of detail about how we could specifically implement networking in our iOS apps. So what we do is we create a network manager class that stores all of our networking call functions, or these are the function calls that we call to the backend API to either post, fetch, delete, or edit anything in the backend. And when we do those things, we use callbacks when making network requests so that we can be notified when the network request is completed. So you guys remember for last lecture, if we don't use a callback for our network requests, we won't be able to actually receive some of the data because our UI updates are quicker sometimes than our network manager calls. So that's why using callbacks is important, because network manager calls are asynchronous. And in terms of communication between the backend, we use a shared language or language independent sort of language called JSON to communicate between frontend and backend. And as you have probably seen from A3, we use get requests and post requests. So to get data and post data simultaneously. Okay, so in today's lecture, we're going to cover something different. This is going to be similar to networking. However, today we're going to be covering persistence. Okay, so I'm going to start with sort of a definition that I really like that Vin created last semester. So you could think of persistence as the idea of storing data on disk without being altered by the user the next time the app is launched. So essentially in the iOS world, this means that this involves storing data locally on the device. So if you guys remember from A2, when you guys sort of ran the app for the first time, you had like the sort of default data that you set when you hard-coded all of the placeholder data. And when you did edit that screen and you ran that app again, you saw that a lot of the data that you edited disappeared somehow. So this is because of data persistence. So a lot of the data that we have in our iOS apps, they're non-persistent, meaning that the data is allocated on RAM, or random access memory, so it's stored on memory. Therefore, every single time you refresh or restart the app, everything is immediately cleared in that memory, so you won't be able to save anything on from your iOS app. So that's the situation with A2. However, with A3, we have API requests. So essentially, you're storing your data to the backend API. So that allows us to sort of have, I guess, kind of a data persistence there. But in this case, we're sort of sending the data via Wi-Fi to our backend. So sometimes we don't actually want to use a backend. So there are a lot of cases with that where especially, either it's inefficient to do so or it just doesn't make sense to do so. So this is where sort of persistence comes in, where it allows us to sort of store our data on local disk so that we either, one, don't need Wi-Fi to access it, and two, so that we have it saved so that every single time you refresh or restart the app, it is still sort of available to all the users, and you won't sort of have an issue where your data disappears. So yeah, so instances where you may have seen this before is, one more common one is like with user settings in your application. So like light mode versus dark mode. Whenever you switch between that, that's not actually making an API request. That's actually just saving whatever settings you have in your actual disk on your computer or whatever application you're using. And I guess another good example of that is sort of like bookmarking or starring. A lot of the time, we don't really want to put that information into the backend. So what we'll do is we'll use persistence to sort of store that information locally so that when you do go back to your apps, you'll be able to fetch whatever saved content that you have from the disk directly. Okay, so there's a lot of different examples of persistence that you can implement in a lot of your iOS applications. There's file system, user defaults, keychain, core data, as well as Swift data and property lists. Just for today, we're going to be going over one of the more simple ones called user defaults. And if you guys are familiar with dictionaries in Swift, this is exactly what user defaults are. You can think of them as sort of a dictionary that represents your disk storage that allows you to sort of store data in key value pairs on your local disk. Okay, so we're sort of going to jump into the demo for today. And I think I hopefully updated the website. I just forgot to earlier today. I think I just did. So if you do sort of go to the website, okay, never mind. That is my bad there. But if you do go to the course GitHub, let me see. You guys should be able to clone this somewhere. Yeah, that's my bad there. But yeah, so you guys may want to follow along this time. And what we can do here is okay, so I guess this is kind of hard to share, but I guess sort of that link here. Let's make this public. Okay. All right. So if you guys do want to follow along, this is the cloning link. I'm going to make that a title there, so hopefully that'll make things easier. Sorry, I forgot to update the website, but that's my bad. But if you do want to follow along, make sure you follow along that link and just clone like you do normally. I'll give you guys like a minute to clone. So make that bigger. Okay. All right, let's get started with the demo today. Okay, so if we sort of pull up our demo for today, so this might sort of seem familiar. This is, if you guys remember from, I believe, L5, which was UI collection view. This is the collection view example we used. However, this difference is that we have sort of saved. So we have favoriting. So you see here, normally when you sort of reset the app, you'll see that everything that you sort of do have saved, so anything edits that you make to the original application when you run it will disappear. But as you can see here, if I do favorite any of these birds and I sort of refresh my app, you'll see that they're actually maintained there. So any edits that I do make to the application, I will have saved in the disk this time. So this is why persistence is important. Okay, so this is the implemented version. So let's get started for today. Okay, so yeah, again, this code might seem familiar. We have our data here, and we're sort of implementing a UI collection view. And like before, we're sort of setting the data source and as well as the delegate flow layout. And if you guys noticed from like the previous lecture, we didn't really cover one of the important parts of UI collection views, and that is how we use the delegate. So this is sort of the lecture where we're going to be doing that. So again, you remember here, we sort of set the delegate as well as the data source, but we actually never do anything with the delegate in the original demo. So today we're going to teach you guys how to sort of use that delegate in this case. So this is sort of what we're going to be using to sort of keep track of clicking on cells, so selecting cells or items. So let's UI collection view delegate. And like before, like any other protocol, we're going to extend our original view controller to our delegate, which is called UI collection view delegate, like so. Okay, so this is sort of where the function that we're going to be using today, which is called the did select row at, which allows us to process interaction with the cells here. So if you see here, like clicking on the cell directly, I don't necessarily have to click on the button here, but clicking on the cell directly actually processes information like that. Okay, so the function we wanted to actually define here is called did select item at. So if you press enter there, yeah, actually that went a little too quick. So if you type in just did select, it should show up as the first thing that pops up there. If not, just give it a minute. It just probably takes a while for the Swift compiler to keep up. You just press enter on that, and it'll give you the stub there. And okay, so what we want to do here now is sort of process the sort of action of favoriting something. So what we want to do is when we click on a cell, we want to favorite the bird that we're clicking here. So, so this sort of action here. And keep in mind, this function is called every single time we click on a specific cell. And when we do click on that cell, we're given the index path of whatever cell we're clicking on. So first thing we want to do actually is get the bird at index. So what we're going to do is define a constant called bird is equal to, and then what we want to do here is go back into our birds data and actually grab that bird at that specific index. So birds, and like we did with 8.3, index path dot row to grab that specific bird at whatever cell is being selected currently. Okay, so once we do that, the next thing we actually want to do is sort of fetch the favorite birds that we currently have stored on our disk. So how we do that is we use, like I mentioned before, user defaults. So step 2 is fetch favorited birds with user defaults. So how we can do that is let's define a variable first called favorites, and let's set that equal to something. We'll be directly calling on user defaults dot standard. And what we want to do in this case is save a list of bird names that we want to have favorited. So array. So we want to sort of establish that we want to fetch an array from our user defaults. So this is sort of how we're going to be fetching our persistent data, is that we're sending whatever favorites variable that we have here to the user defaults array that we're fetching from our disk. So what we want to do here is actually define a key value pair. So our values are going to be the birds that we're favoriting. In this case, we want to specify a key that we want to save that at. So like a dictionary, we sort of can access and store values at whatever key that we specify. So keep in mind, naming for these keys is quite important because whatever key you store to, in order to fetch that data, you need to remember that key so you can fetch that data as well. So what we can do is let's just call this favorites. And this is a string, by the way. And then keep in mind, if we sort of look at the type of what favorites is, you can see that it's a list of any ? So we actually don't want that because we want our favorites to be a list of names. So like we do with the collection view setup, we want to cast this using the as keyword as a list of strings. And then it'll also be optional. So what we want to do is supply it with an optional variable, which will just be an empty list like so. Okay. So now that we have our bird selected and we have our favorited birds that we currently have in our disk, what we want to do is now we want to toggle favorites. So what we want to do is we want to determine when we click, do we either want to make the star disappear or make the star like, filled or unfilled. So that's sort of what we want to distinct right now. So that's what we're calling toggle favorites. And this, we can sort of define a conditional statement here. And we want to see if the current bird that we have selected is within our favorites. So what we can do here is use a function called contains. So we want to see if our bird is within favorites. So we can do favorites.contains. And then we want to check if our bird's name is within our favorited list. So this essentially returns a Boolean and tells us whether or not the current bird name that we have selected is in our favorites list that we fetched from our persistent storage. Okay, and in this case, what we want to do within this if statement, this means that if it is in favorites, it means that the name is already stored in user defaults. And what we want to do in this case is we want to unfavorite it or remove from favorites. Okay, so how we can do that is we can use a function called remove all. So currently we have our favorites sort of array here. So you can do favorites dot remove all. And you click on this where keyword here, you'll see we have this sort of function stub like so. And if you just click enter on that function stub, you'll sort of see it looks sort of treats it like a completion handler and sort of gives you that sort of chunk of code like that. So we can set a variable and we can call it name. And what I want to do here is we want to remove all instances of bird that have the name here. So we can do name is equal to, and we can specify the bird's name. So essentially what this function does is whatever Boolean is satisfied here, it removes it from the favorites list. Okay, so you can see here that we have, I guess, name as our key, if you've noticed. We're storing the actual names into the persistence storage. So this is usually not a good idea. You'll probably see in A4, when we're going to release that later, that when we do use persistent storage, we never want to use things like names. And the reason being is names are sort of, you can share names with a lot of things. A lot of different things can have the same name, but not necessarily be the same object. So if you see in A4, we'll sort of have a custom thing called an ID that each item has that you'll be able to store using that. So rather than storing the name, a lot of the time you kind of just want to store the item ID. But in this case, just for simplicity, we're going to be storing the name because you can see all our birds have different names here. Okay, so in the case that we do have the bird in our favorite list already, we want to remove it from the favorites. And in the other case, else, we want to actually add it to our favorites list. So we can do favorites.append, and we want to append the bird name that we have already. So in the case that we don't have it, it's not in the user, it's already in the user defaults, sorry. We want to remove it from favorites, otherwise, we can say name not stored, and thus we want to add it. Okay. So now that we sort of have that logic for toggling, where did my code go? My bad there. Okay, so now that we have actually toggled, the last thing we want to do here is we want to update our user defaults. So you can see here that we sort of edited the favorites here, but we actually never stored it back into our persistent storage. So how we can do that is we can go user defaults. In this case, rather than using a get method by using array, we want to use something called set value. And you can see that we have two parameters there. So the first thing we want to do in that is whatever value we're setting. So in this case, we want to set favorites, and then whatever thing we want to replace in our persistent storage, we want to specify the key of. And this is sort of where our naming is important, because you can see that our favorites key here has to match this one. Otherwise, we're not saving and fetching from the same place in disk. So what we can do is directly copy this here and paste that in right there. So what this is essentially doing is taking our new favorite list that we either edited or didn't edit and store it back into our disk storage so that we can fetch it later on. Okay, and actually there's one more thing that we need to do, and that is to sort of reload the collection view. Anytime we sort of update our data, we always want to reload that data in the collection view. So what we can do here is we can do collection view.reload data, and now if we run our application, hopefully things will work. Oh, there we go. Okay, so let's sort of test this again. So before we had like the completed code, but now that we have written our code, let's see if our persistent storage is working. So let's see. Oh, so it seems like when we select any of these cells, it's not really doing anything. And that's because we haven't actually, so what we've done is we've processed the action, but we haven't given any visual feedback as to, say that we clicked on the cell. So what we want to do here is actually code the logic for indicating that this current cell is selected or favorited. Okay, so what we want to do in that case is we want to go to our bird collection view cell here, and we want to go to our configured function. So what we want to do here is we want to set an image to be something different depending on if the current bird is in the favorites list or not. So you can see that we have a to do here, so indicating whether we want the star to be filled or unfilled. So we have two different images for those two different states. Okay, so what we want to do here is actually similar to what we did before. We want to fetch our favorites and see if our current bird that we want to configure is in our favorites. And depending on whether or not that is true, we either set the icon to be a filled star or a non-filled star. Okay, so let's do the same thing as we did before, and let's sort of fetch our birds from our favorites. So let's do let favorites is equal to, again, we're calling user defaults, and we want to use standard. And what we want to fetch in this case is the array of birds again, because we want our list of birds that we had before. Okay, and keep in mind, we want to use the same key as before, just so that we can fetch the same birds or whatever data we're storing at this key. We want to make sure that we're consistently using that key name. Otherwise, we're going to be fetching or storing to different places in disk. Okay, so now we have our favorites. Again, we want to cast it to what we want, which is a list of strings. And then we also want to set a default value because this is optional. Okay, so now that we have that, we also want to now toggle again whether or not our bird is in our favorites list. So again, we set an if statement, and we want to check if the current bird here is in our favorites list. So we can do favorites.contains, and we want to check the name of the bird and see if it is in persistent storage. And if it is, we want to set the star icon as filled, so we can just put that in here. Otherwise, we want our star icon to be a normal star that is unfilled, indicating that it has not been favorited, and you can still click on it. Okay, so now that we sort of processed the click, as well as now updating the view to display the click, now I think we should have a working application now. Okay, so if we go here, you can see that when we do click on things, they are registering, and just as test persistence, we're going to refresh the app. And you'll see that, again, our data is now persistent. So every single time you refresh or restart the app, all of your data will be stored, at least the favoriting will be stored. And if you don't do that, if you don't set your persistent storage, every single time you refresh or restart your data, everything will be erased. So this is sort of a way that we can store user data, either favoriting or things like user settings like that, without using a backend API. And, yeah, it just makes things a lot more simpler in a lot of cases. Okay, any questions? Okay. Oh yeah, I guess I'll reiterate one thing, because I think a lot of people had questions about this for A3. So if you see that, we sort of updated this view in our configure function. So we have this favoriting. So anytime we have like interaction with our view, more often than not, we want to sort of process that interaction in our configure function. So, like in A3, when we click on a like button, we sort of want to process that interaction in our configure function, because that allows us to specify that whatever cell we're configuring has that specific click action. Otherwise, if you do that, if you don't do that, you'll have something wonky to where when you sort of read, queue, and dequeue the cells, some of these might be selected because you're reusing a view that has something selected. So what you want to do is actually process these interactions within our configure function, so you never have that instance where you're requeuing and dequeuing a cell that already has the UI modified. Okay, all right, let's go to the second part of our lecture today, and that's going to be, okay, I guess I could reiterate this a little bit. Okay, so yeah, so what we want to do with user defaults is we can first store our data using setValue, like so. And setValue sort of takes in two parameters. Again, it takes in whatever you want to store, as well as the key, the string key for wherever you want to store it. So, wherever you're using this key, you're storing to that specific place in disk. So again, you're storing the name vin to that specific place in memory that is attached to the keyword name. And again, we can also access our data like so. So what you can do here is we access our data using something like string or array or whatever here. So actually, I only demoed array, but you can actually fetch many different things from persistent storage, but you can specify that just by saying user defaults.standard, and whatever type of item that you're fetching, you specify that, and there'll be a custom function to where it'll grab whatever type here from that key. Okay, let's move on to the second part of this lecture, which is going to be SnapKit. Okay, so I guess SnapKit is sort of a way easier way to sort of do constraints and stuff. So I guess just by a show of hands here, who really dislikes using auto layout for constraints? Okay, surprisingly, I would have assumed there would be more, because personally, I despise auto layout. It is a very tedious process. There's so many things that can go wrong. You have to store sort of everything in an entire list of all your constraints there. So today, we're going to go over SnapKit, which is sort of a way that you can simplify very much the constraint making process. So if you're really tired of having long code chunks for setting up constraints, things that should be relatively simple to understand, require like maybe 10 to 20 lines of code, just depending on how much NS layout code you have. So this is where SnapKit comes in. And SnapKit is a wrapper library that makes setting constraints with auto layout very simple. So what it means by a wrapper sort of library, it means that all of these sort of interactions are the same. So you're still sort of using setting that constraints the same way, but SnapKit is doing a lot of the heavy lifting for you, to where it's sort of simplifying the amount of sets that you have to do, and it's converting whatever code you're writing in SnapKit to the respective auto layout code that you would normally be writing. Okay, so we're gonna get started into that demo. So we can go back to the same file that we had before here, and you can see that we've already have everything constrained here. And you can see that, we have let's go back to our view controller, sorry. You can see here we have our collection view. And if you remember from the lecture or just looking here, we're sort of setting our collection view to the top, trailing, bottom, and top anchor. So we have the same constraints as our super view. So our collection view, we want to set as the constraints of our super view. Okay, so we have our NS layout code here. So what we're gonna do here is let's comment this out, and let's replace it with our SnapKit code. So you can see here that SnapKit is a package. So like Almifier, we have to import it. So the first thing we want to do is import SnapKit at the very top, like so. You see there. And what we can do now is, after that comment to code, what we want to do is constrain our collection view. So what we want to do is first specify what we want to constrain, and that's going to be our collection view. And the second thing we want to do is specify that we want to use SnapKit. Otherwise, it won't recognize what we want to do here. So how we do that is we use the keyword SNP, indicate that we want to start using SnapKit, and then we press dot again. And you can see that the first thing that comes up is called make constraints. So you click enter on that. You'll see we sort of have a closure here. And like, callbacks, we sort of have that auto completion just by clicking enter. And you'll see we have this variable called make. So what make represents in this case is whatever we're making the constraints of. So our collection view is essentially represented by this variable make. And since we want to set the collection view anchors to the anchors of the super view, we can actually do this by just doing make dot edges dot equal to super view. And believe it or not, that is it. So in doing this one line of code, you're sort of setting the leading, the trailing, the top, and the bottom anchor equal to the super view. So this make represents the collection view, and you're setting the edges of that collection view equal to the super view. And actually, this only works if your constraints are the same. So you can see here that we're sort of setting the leading, trailing, top, and bottom anchor of our collection view equal to the respective anchor in the super view. So instead of doing them individually, SnapKit allows us to set everything at once by using this sort of edges keyword. Okay, so let's move on to the next section here. And I think that's it for constraints here. But if we go into our bird collection view cell, we sort of have more auto layout code that we can replace here. Okay, so you can see here that we have our bird image as well as our bird label that we want to constrain this time. And if we go here, we're sort of constraining this to the center, and we're putting this label underneath. Okay, so what we do here is let's comment this out again. And like before, what we want to specify here is that we want to make the constraints of the bird image. So we specify the bird image first. And then now we want to specify that we want to use SnapKit by using the keyword SNP. And then we want to make constraints and click enter on that closure. And again, I'll reiterate, make sort of represents whatever we're making the constraints here of. So you can see we want to make the bird image's center X anchor and center Y anchor equal to the content view's center X and Y anchor. And keep in mind the content view is the super view of the bird image because the bird image has been added to the content view. And SnapKit is able to recognize this. So then we don't have to specify what specific view we want to put. We can just specify that we want to constrain this to the super view. Okay, so like before, we want to do make dot, and then we want to specify the center X and the center Y anchor, And luckily, SnapKit allows us to combine that into one and call that center. And then we want to make that equal to the super view. Okay, so we've now knocked out those two constraints just from this one line of code. And we also want to do here is we want to set the height anchor and the width anchor to 128. So how we do this is you can specify make.size equal to 128. And because our image is a square, we don't have to specify the width and the height. We can just use the size constraint, which allows us to set both the width and the height to be the same thing, ensuring that it's a square. If you do did want to make something different, you have sort of height and width anchors as well. So you don't necessarily have to set everything to a square. You have that freedom to sort of set the width and the height independently. But just so we can save some more code and make it look way more clean, we can just use the size attribute here to specify that we want to make this image a square with dimensions 128 pixels. Okay, so now we have that done. We have a few more things to do. We also have this label here. So again, let's comment this out. And we want to constrain our label again. So this time we still have to specify what we want to constrain. So in this case, it would be the bird name label. And then we use, again, snap to specify, and we want to make constraints. And now this time, we want to set the center X anchor equal to the content view. So again, this will be similar to before, but we're only setting the center X. However, this time, it's a little bit more complicated because we want to set the top anchor of the bird name label to the bottom anchor of the bird image. Okay, so first let's get that center X anchor out of the way. So you can do make.centerX equal to super view, because content view is the super view here, and SnapKit is able to recognize that because we added our current bird image or bird label to the content view. So we don't actually have to specify that it's the content view because SnapKit already knows this. Okay, and the next thing we can do is we want to set the top anchor of our bird name label to the bottom anchor of our bird image. So again, we want to set the top anchor. So we want to specify make.top, and we want to set that equal to, so rather than equal to super view, we want to specify that it's equal to something else. So now what we want to do is we want to make sure that we're setting it to the bottom anchor of the bird image view. So what we can do here is actually put that constraint there. So what we want to do is put it at the bird image. And then again, we want to specify that it's a SnapKit constraint. So we want to use snap. And then now we can just specify that we want it at the bottom. So essentially we're constraining the top of the name label to the bottom of the bird image label. And you can see that we also want a constant here. So rather than directly putting that in the parameters of equal to, there's something separate called offset that allows us to specify that we want to offset our current constraint by whatever constant that we have here. So instead of putting constant here like this, we're putting an offset here indicating that we want to make the top anchor equal to the bottom anchor of the bird image and offset it by 4 so that we have that sort of spacing in between there. And you sort of wanted to do negative constants, like let's say you wanted to move it closer for some reason. Normally you would specify -4, but in this case, instead of offset, you could just specify inset, and that sort of indicates that we want a negative offset or negative constant. But in this case, we want to sort of separate a little bit so there's more distinction, so we're using a offset in this case. Okay, so we have that done here. And last but not least, we have sort of the star icon we have here at the very top here. So again, let's replace this constraint with some SnapKit code just to make our code a lot cleaner. So we want to constrain the star icon and specify that we're using SnapKit. We want to make constraints like this. And make represents our star icon, so we want to set the top anchor, the trail anchor, equal to the content views, top and trail anchor, and the width anchor and height anchor to our size of 24. So what we can do here is make.top equal to super view, because content view, again, is the super view in this case. It is a view that the star icon is on, and SnapKit is able to detect that, so you don't have to explicitly state that this is constrained to the content view. And we want to specify the trailing, so we can do trailing equal to super view. Again, this is doing the same thing. And then last but not least, we can sort of set the width and the height anchor by using our size keyword again. So make.size equal to, and we want to specify that we want to make it a 24 by 24 square here. Okay, so we can actually simplify this code even more. So if you see that we have top and trailing here, this is sort of repeated. We're both setting the top and the trailing equal to the super view. So you can do here is, since we're setting these to the same constraint, which is to the super view, we can actually chain them back to back. So So you do top dot trailing dot equal to superview. So what this does is allows us to chain these two constraints and set them both equal to the superview. So again, this is sort of like syntactic sugar that allows us to limit the number of lines of code that we're writing here. And this is doing the exact same thing that auto layout is doing up here, just in a lot less lines of code. So you can see that we commented out so many lines of code, and we sort of replaced it to 4 to 5 lines of code. So especially in large scale applications, this makes setting constraints a lot cleaner and a lot easier. And you can see it took a lot less time to type because there's just, you don't have to keep typing star icon, top anchor, trailing anchor again. It sort of saves you all of that typing and simplifies everything to one centralized package where you can do constraints without sort of having a headache of keeping track of a list of constraints. Yeah, what's up?
So is there a reason that we learned the previous way?
Yeah, you guys are probably saying like, oh, why did you guys teach us the hard way first? So we used SnapKit. So I guess the reason why we did that is that you guys sort of understand what constraints mean in this case. Because here, I feel like the sort of concepts behind it are sort of hidden behind this wall of, abstraction that you guys really won't understand what we're doing directly with the constraints here. So we also want you to understand that SnapKit is not like its own sort of thing that's integrated in Swift. It's an additional package that's sort of added on to what we use normally, which is auto layout. So it's using the exact same process, however, it abstracts a layer over it. So I guess sort of the understanding is a little bit gone there. But now that you guys sort of understand how auto layout works, we're teaching you now SnapKit to sort of make your coding a lot easier, while you guys still understand how constraints at its very core works. So hope that answers the question. Okay, any other questions? Okay, nice. Yep, actually, let me just run this first to show you guys it's the same thing. Yep, so you can see that the code literally had no change whatsoever, despite losing like 20 lines of code just from changing the constraints to this more simplified version. And I guess what you guys can do is, if you want to sort of add SnapKit to your Hack Challenge project or any other project in the future, you can actually look up the GitHub repository for SnapKit by searching on Safari or anything like that. And you can right-click in this Packages section, and you can do Add Package Dependencies, and merely just paste that GitHub link right there, and it'll sort of allow you to add that package so you can use and import it in whatever project you want. So this applies to any sort of package you want in the future. If it is like sort of Swift integrated, you can just copy the repository link, paste it in this sort of package area here, and you'll be able to actually use that package just to save you a lot of time or anything like that. Okay, so that concludes this section of the lecture. All right. And I believe that is it in terms of concepts for this lecture, so we can move straight on to the Kahoot, unless you guys have any questions. Okay, perfect. Again, I don't know why the music's not working. They changed the setup in here, so nothing's working anymore. All right, everyone in? Okay, let's get started. Okay. First question, where is persistent data stored? Okay, nice. So yeah, it is actually not stored in memory. So normally when you have your iOS applications, like in the situation with A2, all of your data is stored in memory so that when you refresh the app, everything is sort of erased. However, in this case, when we're using persistent data, we're actually saving everything to the disk so that when you do reset the app or restart your iPhone, everything is still sort of stored there and you can get it back later. Okay, nice. Okay, next question. Non-persistent data is cleared when the app restarts. Kind of already gave this away already. Yep. So when we do not have persistent data, when we do refresh the app, everything you previously edited or stored in memory will be erased. Okay, nice. All right. Last question. When is the hack challenge mixer? Yep, that is right. That'll be April 19th, which is actually this Friday. And the location, I believe, at least for now, is PSB 120. So if there are any updates on that, I will sort of ping you guys on the EdStem as well as the hack challenge EdStem. Okay, nice. Let's see. All right, nice. And the glitch is back. All right, nice. Okay, let's just end today with some announcements here. Okay, so just in terms of to-do, so keep in mind A3, the final submission is due tomorrow night. So make sure you guys, again, the submission process is like A2, where you're submitting a text file with your GitHub, your username, your NetID, as well as your name. And also keep in mind these sort of dates that are coming up, and with the Hack Challenge Team Mixer being Friday, from 4:30 to 6:30 p.m. in PSB 120. And this is sort of the same day that our team matching form will be due as well. And I'll be making an EdStem post after lecture today, or you can refer to the Hack Challenge EdStem that I've added all of you guys to here. So there'll be a write-up here as well as a team matching form that you'll be able to fill out here. And I would fill out the team matching form regardless whether or not you know your teammates or not, because we sort of have preferences on there for us to match you with a team if you're unable to find a team by yourself. Okay. And last but not least, the Hack Challenge Kickoff is sort of where we're going to be introducing the rules as well as the process of how the Hack Challenge is going to work. And by that time, you'll probably already have your groups there. So we'll be announcing groups actually during the Hack Challenge Kickoff. So this is required for anyone who is taking the course for credit or participating in the Hack Challenge. And that, again, is in PSB 120 from 4:30 to 6:30 p.m. Okay, yep, that's it for lecture today. And if you guys have any questions about anything, feel free to come up.